Math 3, Classwork 1.1, Part B, Graphing Equations. If you have not attempted graphing your absolute value of x, pause the video. Now, turn it back on and let's take a look at what you should have found. You probably remember this looks like a V graph. It has a very sharp point right here. The table of values, you can read it, make sure you have the correct things. The important features are domain is all the x values from negative infinity to positive infinity, and that's looking at horizontally. The range is looking vertically. The graph does not exist under the x-axis, so there are not negative y values. The range is 0, including 0, to infinity. The vertex is the point 0, 0, right there. So you need to make sure that you know this graph, and then you need to be able to sketch some transformations. So if you don't remember how to do transformations, just keep watching. If you think you remember, pause the video, see if you can do it. All right, here we go. When you multiply the function by a number, you are taking the y values and squishing them down or stretching them out. The thing with the multiplication to the function itself is it does exactly what it seems like it's going to do. Multiplying by 1/2 makes you think squash, and it does. So it squeezes everything toward the x-axis. So what you can do is you can multiply all the y coordinates that you had gotten from the parent graph, multiply them by 1/2, and then keep those x coordinates and draw them. Now, for example 6, what I've done is I've taken from the point where you've already multiplied by 1/2. Now you are going to shift the graph and you're translating it. If you remember from a long time ago, when you subtract 3 from x, you're actually moving it right 3. Anything that happens with the x affects it horizontally, but it does the exact opposite operation. Then the -4 outside of the equation affects the up and down the y value, and it does exactly what it says. -4 means bring it all down 4 units. So you're going to take the graph you got for 1/2 absolute x, move every point right 3 and down 4. So let's take a look at the answers. So these are what your graphs should look like. And then the domain stays negative infinity to positive infinity. The range, the y values are including 0 up to infinity. Multiplication did not affect the range, but shifting it vertically did. Then the vertex is 0, 0 still when you multiply, but once you translate, then the vertex is 3, -4. Now, do you remember the graph of y equals x squared? So I want you to now pause the video if you have not yet done this graph. Fill in the f of x values, see if you remember the important features, and maybe see if you can do the transformations to that parent graph on your own. So pause. And the answer. So y equals x squared, the parabola you're familiar with. Make sure that you know these designated points. All right here. Domain negative infinity to positive infinity. The range includes 0, so square bracket. The vertex is the point 0, 0. When you multiply by 2, you're taking the y values and you are stretching them. You are multiplying every y value by 2, and you can see that this is stretched from this graph, vertically stretched. Then +3 with the x actually means left 3, go -3 basically. You have to do opposite operation with what's inside the function with the x. And I want to point out again, I had multiplied by 2 for this. I am still multiplying by 2. It's just my new thing is the +3 and the +1, which just move it from this state. So move right 3. I apologize. Left 3. And then up 1. When the addition subtraction is outside, it's always exactly the direction it says vertically. And domain, range, and vertex. All right, now one more graph. And if you think you know how to graph this, pause the video, see if you can do it, and do the translations. If you think you can go that far on your own, pause the video on that as well. If you're not sure what to do, then follow along. So the square root of x is only a partial inverse of your parabola. It's only half of a parabola. So you cannot plug negative numbers into a square root. You get undefined. And you should see that same parabola nature, just it reversed x and y. And this time the domain is not everything from negative infinity to positive infinity. The domain and range are both inclusive of 0 to infinity. And the end point I'm referring to, I have to get my pen. I am referring to this endpoint right here is the point 0, 0. I will be asking for endpoints, so you're following that point. Now, if you want to try the transformations on your own, pause the video. So multiplying by a negative number, if you literally take all of the y coordinates you see here and multiply them by -1, 0 is still 0, but now all these are negative. So they would keep their x coordinate, but all the y coordinates are going to reflect over the x-axis to draw what is the bottom half of a parabola, a sideways parabola. Notice that the range changes. So the range is from negative infinity to 0. I did something and it's not drawing for me. So anyway, hopefully you can see that there. And then the endpoint is 0, 0. The negative sign that we had over there is remaining here. And when you see +2 inside the function with the x, that actually means more like subtract 2, move left 2 units. And then if it happens outside of that square root, then it affects y, and vertically, just do the direction it says, go down 3 units. And so we get this graph. You can see domain, range, and endpoints. And if you have any questions, make sure to ask. That is the end of Classwork 1-1.